Hello everyone, welcome back to my YouTube channel. So now we are going to solve day 3 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3304. Find the kth character in string game 1. So let's read the problem statement first. Alice and Bob are playing a game. Initially, Alice has a string word is equal to A. You are given a positive integer k. Now Bob will ask Alice to perform the following operation forever. We have to generate a new string by changing each character in word to its next character in the English alphabet and append it to the original word. Okay, so for example, performing the operation on C generates C and the next one, okay, D, okay, and performing the operation on Z and B, so Z is going to change to A and this B is going to change to C. Okay, next, so it is going to generate Z B A C. Okay, overall, right? So we have to return the value of the kth character in the word after enough operation have been done for word to have at least k characters. Okay, and note that the character Z can be changed to A in the operation, right? So now see this example number 1, k is equal to 5. Okay, so initially we have A, right? Okay, so length is just 1, right? Now in the next operation A, and what is the next of this A is nothing but B. Okay, so length is 2. All right, still length is not 5, right? So next time we have AB, so A's next is B and B's next is C. Okay, so this is my next word, and here if you see, still length is just 4, okay, of this one, right? So here I can say 2 power 0, I can say it 2 power 1, I can say it 2 power 2. Okay, so length is doubling every time, right? Here still my k value is 5, but still length is not 5, right? So next time again I'm going to take this particular word only, A B B C, A B B C, right? And here A's next is B, B's next is C, this B's next is also C, this C's next is D. Okay, so this is my next word, right? And what is the length of this one? 1 2 3 4 5 6 7 8 8, or I can say 2 power 3. Okay, so this is also doubling every time, right? So now k is equal to 5, right? So 1 2 3 4 and 5. Okay, so at 5 we have B, so this is my output. Okay, so this is what we need to do. Same way, this is example number 2. Okay, and these are the constants k from 1 to 500. So let's solve this problem using StringBuilder first. Okay, with StringBuilder it is very easy, right? So we are just going to take this string and we are going to check side by that my length is not exceeding the k value, right? And I will just generate a new string again and again. Once I form a StringBuilder of length greater than this 5, right, I will stop. Okay, and I will just get that particular value, okay, from this position, right? So it's very simple. So let's write the code. So here string builder sb is equal to new string builder, and here initially what we have a, right? So here I'm just going to pass this a string. Done. Okay, and now next time here we have to just run one simple while loop while this sb dot length. Okay, if it is less than k, okay, until then only we have to do, right? So actually if you read this, okay, this string builder, so indexing is going to start from 0 1 2 3 4. Okay, so that is why I'm saying less than k. Okay, so until here only we need, right? So indexing is going to start from 0, right? So here while sb dot length is less than k, and here inside this I'm just going to first get the length of this. So length is equal to sb dot length. All right, and this is done. Now here inside this I'm just going to write one loop for int I is equal to 0, I is less than length, and here I plus plus. Okay, and here after that just take the one particular character, char c is equal to sb dot char at this index I. Okay, so now we have to take the next of this, okay, one by one. So next I can say char new char. Okay, so here what I need to do first, this is my character c, right? C minus a, so I will just get the index, right? 0 1 2 value. Okay, if my c is a and here I'm subtracting a from it, I will get 0. Okay, so in this 0 I'm adding what? I'm adding 1. Okay, and let's suppose here my c is 25 25 my z. Okay, So z minus a, I'm going to get 25. So 25 plus 1 is equal to 26. So here a to z, right? So a is starting from 0, right? And this is 25. So now if I'm adding plus 1 here, so I will get 26. So 26 itself is not there, right? We have a to z only. So after that I need to take a, right? So I will just take the modulus of 26 with 26, right? And it will just give me my 0 value, right? So here same way, if you do 27 modulus with 26, what you are going to get? You are going to get 1. That simply means b. Okay, 26 modulus with the 26, you are going to get nothing but 0. That simply means a, right? So here this is just a way of writing. Okay, c minus a plus 1, right? And here I will just do the modulus with the 26, because after z I need what I need a, right? So this is done. Okay, this is done until here. All right. So now after this, what I need to do, I also need to change this to a new character, right? So here I'm just going to add a, so I will get a new character after this. Okay, so here just place it like this, and here what I need a character. Okay, so here before this I will just write char. Okay, so I will get a character. Okay, this is done. So this is my new character, and I'm just going to append this to my string builder. Okay, sb.append, right? And this is nothing but my new char. Okay, that's it. So now as soon as my sp.length becomes greater than or equal to k, I will just stop, and in the end I will just simply return the sp.char at k minus 1. Okay, because the index is going to start from 0, right? So sp.char at, and here I will just simply write k minus 1. Okay, that's it, right? So now let's run the code and see if there are any code issues. We'll try to fix that. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? And the time complexity of this problem is going to be O of k, right? Because we are just forming a string of length k, right? So time complexity is going to be O of k for this, right? So this is one approach, right? And there is one more better way to solve this, that is using bits. Okay, so for that actually you guys need to know a few things. So let's read this. So this is approach 2. Okay, so in approach 1, my time complexity is going to be O of k, and O k is nothing but the length, okay, that I need to form. Now I will just solve this problem using O of log k time complexity. Okay, so for that, first let's understand what is a Java int type. Okay, so Java int is a 32-bit signed integer. Its bits range from index 0 to, in 0 is nothing but most significant bit, to index 31, that is least significant bit. Okay, so the highest bit index is 31. All right, and there is one more method that I'm going to use, is integer dot number of leading zeros. Okay, and here I'm just going to pass k value. So what this method is going to do, it is going to count how many zeros appear before the first one bit in the binary representation of k. Okay, so let's suppose your k value is 10. So how you write k in binary form? 1 2 4 8. Okay, so you are going to write 10 like this now, 1 and 1 here like this. Okay, 1 0 1 0, right? So here what are the number of zeros before this? Okay, so if you count this, 1 2 3 4 5 6 7 8 8 16 24 25 26 27 28. Okay, so total 28, right? So to find the highest set bit, the most significant one in k, okay, that is this position, right? This position you need to find, okay, where first one occurs. So total is nothing but 31. Okay, highest bit index is 31. So in this 31, if I subtract 28, what I will get? I will get 29 30 31 3. Okay, so that's right now. So here this is nothing but 2 power 0 2 power 1 2 power 2, and here this is nothing but 2 power 3. Okay, so that's right? So int highest bit is equal to 31 minus integer dot number of leading zeros k, right? So total bits 32. If the first one appears after n zeros, then the index of first one is 31 minus n, right? So this gives a position of the highest bit, which represents the largest position of 2 less than equal to 3, right? So I hope that you guys are clear, right? All right, so here same way, int k is equal to 18. So again we have to find this. So highest bit 31 minus 27 4. Okay, 2 power 4 16. Okay, so 2 power 4, okay, until 2 power 4 we have 16, right? And we need 18, right? So 31 is used because Java int has 32 bits, right? Indexed from 0 to 31, and 31 minus integer dot number of leading zeros k is going to give you the position of highest set bit in k. Okay, so now why we are actually doing all this? Okay, so here in the starting I told you that every time length is getting doubled. Okay, so first 2 0 length, then 2 power 1 is the length, then 2 power 2 is the length, then 2 power 3 is the length. Okay, so on. So this is how length is increasing, right? It is doubling every time, right? So just understand the sequence first. So we have this a first, right? And we are starting from here. So this is nothing but 2 power 0. S1, S0, S0 is equal to 2 power 0, right? S1 is nothing but 2 power 1. Okay, so length is AB, right? A and next is B, so merging together AB. S2, so this is nothing but 2 power 2. Okay, so AB, BC, so 2 power 2. Okay, this is nothing but 2 power 1. And same way here 4 and 4. Okay, so here this is number 2 power 3, right? S3 is 2 power 3. So same way I can say that length of SR is nothing but 2 power R. Okay, like this, right? So think about this recursively, the sequence at level R. Okay, I can say first we are taking previous one S1, taking previous one S0, this one, and the next of this. So S of R, S underscore R is nothing but S underscore R minus 1, and the next of this S underscore R minus 1. Okay, so this is how we are forming, right? And it is doubling every time. Now in order to find the kth character, so if k lies in the first half, it comes from this one, this part. Okay, then we don't need to find out this. But if k lies in the second half, then it is nothing but the next of all the characters one by one of this one. Okay, right? So we can reduce the problem to a smaller k at a lower level recursively and apply next if we went into the right half. Okay, so this is actually what we need to do, right, for this particular problem. So here if we I write here, see, 1 2 3 4 5 6 7 8. Okay, so a b b c, and this is one half, right? So what we need k is equal to 5, right? So here k is equal to 5 is what we need, right? So first 5 I'm going to write it in binary form. So 1 2 4, so it is nothing but like this. Okay, right? And here's there are so many zeros here. Okay, until 31. Okay, so 2 power 31 until here. Okay, this is nothing but 2 power 0. Okay, so until here, so 31 minus here first number of zeros we have to calculate. Okay, so this method is going to give me the number of zeros. Okay, number of leading zeros of k. Okay, so what I will get something in total if I just calculate. So 2 power 0, 2 power 1, and 2 power 2. Okay, so here 2 power 2, right? So I will get maybe 29, right? And I will get here 2, so 2 power 2. Okay, so here this is the value that I'm going to get. Okay, 2, right? Okay, so now after that what we need to do, so here I'm just going to calculate the highest bit. Okay, highest bit where 1 is starting. Okay, so here I will get 2. Okay, so now here after this what we need to do, I'm just going to check what is my k value. K value is 5. Okay, so if I left shift this 1, okay, that suppose this is 1. Okay, so if I left shift this 1 with 2 times, okay, this 2, so I will get something like this. Okay, so this is nothing but 1 2 4. Okay, so this value is nothing but 4. Okay, this value is nothing but 4. So 4 is less than 5. Okay, 4 is not equal to 5, right? So what I'm going to do, so that simply means that my value is going to occur in the second half. Okay, this half. So what I'm going to do, I'm going to subtract k, and k here, k minus, and left shift what we did here 5 4. Okay, what we get 4 here, so 5 minus 4. Next time my k is going to become 1. Okay, k is going to become 1 here. So I will write the code, then you guys will get better understanding about this. Okay, and let's write the code, right? Okay, and here let me just discard. So here you are going to get 1. Okay, and at 1 you have to just simply stop, because we need k values from 1 to 500 only. So until 1 only we need to search. Okay, and here we are just moving one time. Okay, so a is next is b, so we have to return that b. Okay, so let's write the code. So here what you need to do here, int depth is equal to 0. So here this is nothing but how many times we go to the second half. Okay, let me add the comment, how many times we go to the second half. Okay, each adds each adds +1 to char. Okay, this is done, right? So here in this problem only one time we are moving to the right, so +1 we do, so in the A, so I'm going to get B. Okay, so this is one thing, right? And here only until while my K is not equal to 1. Okay, K is not equal to 1, so K is starting from 1, so only until here, right? Okay, so we have to find out the highest power of 2 less than or equal to K, right? So here let me add the comment, find the highest power of 2 less than or equal to K. Okay, so here what you need to do, highest power, highest bit, okay, int highest bit is equal to 31 minus the formula, okay, that integer dot function number of leading zeros. Okay, so here just pass K. Okay, so here you are going to get the highest bit. Okay, int highest bit is equal to 31 minus integer dot number of leading zeros in K. Okay, so now in this way we are just going to get the highest bit. Okay, now I will check after this if you can say K is exactly a power of 2. Okay, K is exactly a power of 2. We want to go one level up, we want to go one level up. Okay, so here if 1 and here left shift with this highest bit. Okay, this is what I need to do, highest bit. Okay, so here if this value is equal to K, okay, 1 minus this highest bit. Okay, so if this value exactly equal to K, then in that case just subtract highest bit minus minus. Okay, bit minus minus, right? And here move to the second half of the level. Okay, so move to the second half of the level. I will tell you why we are doing this. Okay, so then we have to just subtract my K as K minus. Okay, and here you have to do just this. Okay, 1 left shift highest bit. Okay, so just pass this value, done. And here you have to just increment the depth plus plus. Okay, so how many times we go to the second half, each adds +1 to the char. Okay, so depth plus plus, done. And in the end from here we have to simply return, we have to return char, right? So depth is going to add one character every time, right? Each adds +1 to the char. Okay, so here I will take this A, and here I'm just going to do depth. Okay, right? Okay, this is done, right? So now let's run the code. Okay, so here this is not required. Okay, so let's run it again. All right, so the test case has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So here why we are doing this, so let's understand with this example. Okay, so here instead of K is equal to 5, let's say I am asking for K is equal to 4, right? So then here again 4, how I'm going to write 1 2 4 8 4, I'm going to write like this. Okay, in binary form. So again you are going to get 29 31 minus 29 2 power 2. Okay, until here only. So now here you are getting highest bit as 2, right? 2 value. So now if you don't then do this, okay, so K is equal to 1 left shift 2, so you are going to get K 0, but we don't need K is equal to 0, right? We need K until 1 only. So that is why here I'm checking if it is equal to K, right? Then we have to take the highest bit, because here we don't want to move to the next stage. Okay, so here I don't want to check this. Okay, I can simply check from here. Okay, so this is gonna say what this is what we need, right? Fourth one. So C is out, right? So that is the reason, right? So here we are going to do that +1, right? Okay, +1. but here before that 1 minus highest bit is equal to k. So highest bit is equal to 2, so 1 left shift 2 is equal to k value is nothing but your 4, right? So here this is 4 and this is also 4, so highest bit uh, you have to subtract. Okay, so now after that it is highest bit is going to become subtract highest bit is nothing but 2 1. Okay, it is going to become 1. So now here k is equal to k minus k is nothing but initially it's minus 4. Okay, it's 4 only, 4 minus and this highest bit you did, right? 1 minus 1 uh 1 highest bit. Okay, highest bit 2, now it is going to become 1, so it is 1 only, so k is going to become 3 now. Okay, so k is becoming 3 and depth is going to become depth is incrementing. Okay, so k is 3 now. Again you have to do. Okay, so 31 minus 4 3. Okay, 4 3 1 2, so until here 31 1 you are going to get, then it is going to become 1, but that is going to be incremented. Okay, so just try with some other examples also. K is equal to 10, you can try. Okay, and you will get this. Okay, so I hope that you guys are able to understand this, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you, bye bye.